Hello students, welcome to Learner's Planet. And students, this is our fourth theory session for physical and chemical changes. So till now we have discussed about the few examples of physical change, chemical change, and also the classification of chemical substance into elements, compounds, mixtures. And in this session we will be studying about the elements, the chemical representation of elements. The chemical changes, that is, chemical changes are also known as chemical reactions, or chemical changes occur due to chemical reactions. So we'll study about those changes in this session. Chemical symbols. The abbreviations used to represent elements are called chemical symbols. So students, elements, the name of the elements cannot be written like that. So every time you can't write the long names of the elements. Like you can't write, say, nitrogen, complete, oxygen, carbon, like that. So there are certain abbreviations which are used to represent these elements. But initially, say, now let's see what is a symbol. A symbol is basically the short form of an element laid down by consensus so that it has universal recognition. The symbols should be universally recognized. It is not that, say, in India I am writing symbol of hydrogen like H. In other parts of the world they are writing like H, Y or HR. It should not be the thing. There should be one single letter abbreviation for hydrogen, right? So the symbols should be laid down by the consensus. Now, in earlier days, these symbols were pictorial in nature. That is, pictures were used to represent elements. Later, Sir John Dalton, an English scientist, created his own set of symbols for elements known in his time. These symbols were again pictorial in nature. So Sir John Dalton, he created some set of symbols. For what sort of symbols? Pictorial symbols, right? That were known at his time. Now they were, see this table. See, Mercury. Mercury is represented by this symbol, right? Hydrogen is represented by this symbol. Arsenic is represented by this symbol. Copper is represented by this symbol. Copper, the Latin name of copper is cuprum, right? So all the, say, names indicated here are not the Latin names, right? So the Latin name of copper is cuprum. Likewise, iron was represented by this symbol. Copper had two symbols, 1 and 2, the pictorial symbols. Likewise, silver, the pictorial symbol was this. Carbon, the pictorial symbol was a simple dot. Oxygen, the pictorial symbol was this. Lead, the pictorial symbol was this. Sulfur, the pictorial symbol was this. And phosphorus, the pictorial symbol was this. Now students, there was a few elements at that time known, so they used to, Sir John Dalton used certain pictorial symbols to indicate these elements. But today there are 114 elements known. So we can't remember so many symbols for those elements. There has to be some different approach for representing an element. So later, the modern system of representation was given by Berzelius. Instead of pictures, he made use of letters of the English alphabet to represent various elements. So letters of English alphabets were used to represent various elements. It is one or two letter internationally agreed code for an element, usually derived from the name of the element in Latin. So it's simple one or two letter code. Let's see what is it. See, the important features of this system are as follows. The first letter appearing in the name of an element is used as its symbol. For example, the symbol of hydrogen is H. See, what is the first letter appearing in this? It's H. For carbon, the symbol is C. What is the first letter appearing? It's C. For oxygen, what is the first letter appearing over here? It's O. Nitrogen, what is the first letter appearing? It's N. So the symbol is N. Likewise, C for phosphorus, what is the first letter appearing over here? It's P. So the symbol is P. Sulfur, what is the first letter appearing over here? It's S. So the symbol is S. Fluorine, what is the first letter appearing over here? It's F. So these are the simple representation of elements. So you know the name of the element and you can represent it by its first letter. But it doesn't happen always. See this, when two or more elements have their names beginning with the same letter, then what are you going to do? Then one more letter is added to the symbol. Say when two or more elements have their names beginning with the same letter. For example, say for some elements the second letter in their name is added, such as for calcium, cobalt. See, both are beginning with C. But you can't use C for both the elements. For calcium, it is used as Ca. For cobalt, it is used as Co. Likewise, see carbon. Carbon also begins with C. So you can represent carbon with C. But chromium is again beginning with C. So it is represented as Cr. Right? Like xenon. Xenon is beginning with Xe. So its symbol would be Xe. Always remember, write the first letter capital and the smaller the small letter or lowercase letter. The second letter the lowercase letter. See, the first letter should be the uppercase and second letter should be the lowercase. Now helium, it is beginning with He. So what will be its symbol? Uppercase H and lowercase e, He. Bromine, it is Br. Right? Now, say in some cases another distinct letter is used, that is chlorine. For chlorine, it is not represented by CH. It is represented by Cl. Right? See your chromium. Chromium is represented by Cr, not CH. Chlorine is represented by Cl. Likewise, magnesium is represented by Mg, not Ma. Manganese is represented by Mn, not Ma. Zinc is represented by Zn. Right? So these are the symbolic representation of few elements. Now let's see the students. This is again a table given over here. Here say not all the names are Latin names. Latin names are given in the brackets. Right? Now element, say aluminium. These are all English names. And the one which is given in the bracket is the Latin name. Right? So aluminium, what will be the symbol? Al. Barium, what will be the symbol? Ba. Boron, what is the symbol? B. Neon, what is the symbol? Ne. Uranium, what is the symbol? U. Fluorine, the symbol is F. Gold, its symbol is derived from its Latin name, that is aurum, Au. Mercury, its symbol is derived from its Latin name hydrargyrum, that is Hg. Lead, its symbol is derived from its Latin name plumbum, Pb. Iron, its Latin name is ferrum and its symbol is derived from it, Fe. Likewise, potassium, its symbol is derived from its Latin name kalium and symbol is K. Silicon, its symbol is Si. Silver, its symbol is Ag. It's derived from its Latin name argentum. Iodine, its symbol is derived from this English name I, and it's I only. Sulfur, the first letter of the name. Sodium, its symbol is derived from its Latin name natrium, that is Na. Phosphorus, it's the first letter of its name, P. Lithium, it's again Li. Nickel, its symbol is Ni. Copper, the symbol is derived from its Latin name, cuprum. So these are some common elements, right? Now, what is the significance of symbol? A symbol represents the following. First of all, it is abbreviation for a particular chemical element. So you can't write the complete name. Say hydrogen, nitrogen, phosphorus, neon, all those things. You just need a short abbreviation. And second thing, single atom of that element. So any symbol represents the single atom of that element. For example, Cl is a symbol and it represents element chlorine and one atom of chlorine. Say it's Cl is a symbol for chlorine. Likewise, H is a symbol for hydrogen and it represents one atom of hydrogen. Likewise, C, carbon, it is a symbol for carbon and it represents one atom of carbon. Right? So this is about the symbols of the elements. Now we'll be proceeding to the chemical formulae. Now the chemical formulae, what is it? The chemical formula of a compound is its symbolic representation. It gives information about the number of atoms in its one molecule. Say I'm writing. Now let's see how we can write a chemical formula. Chemical formulae of elements. The chemical formula of an element is represented by writing the symbol of that element and indicating the number of atoms in one molecule of it by a subscript on the right hand side of the symbol. I'll simplify it. Let's write the formula of oxygen. Now, oxygen atom cannot exist independently. Right? So, atom, what is an atom? Atom is the smallest unit of an element. So, atom of oxygen cannot exist independently. Right? So, two atoms of oxygen combine and they form oxygen molecule. So, how is oxygen represented? The symbol for oxygen, that is O, followed by the subscript. This subscript indicates the number of atoms. So, it's 2. Now, let's see few more. Like, I have to write chlorine. Again, an atom of chlorine cannot exist independently. Right? So what happens? Two atoms of chlorine combine and they form chlorine molecule. and chlorine exists as chlorine molecule. Now, what is the symbol for chlorine? Cl. How many atoms make one molecule? 2. So, we will write 2 as a subscript. Isn't it simple, students? Likewise, say if I have to write nitrogen, chemical formula of nitrogen. Now again, an atom of nitrogen is unstable. That is, it cannot exist independently. Right? So, in this case, two atoms of nitrogen, they combine and they form nitrogen molecule. Now, what will be the formula of nitrogen? Symbol of nitrogen followed by the subscript 2. Why 2? Because there are 2 atoms of nitrogen. Likewise, if I take sulfur, again its single atom is unstable. Now in this case, students, 8 atoms of sulfur, they combine. How many atoms are there now? 5, 6, 7 and 8. So 8 atoms of sulfur combine and form the sulfur. So how will it be represented? Symbol for sulfur S. How many atoms are there in its molecule? In its one molecule? 8. So it's 8. So how many atoms are there in one molecule of sulfur? 8 atoms of sulfur are there in its one molecule. So this is the way how the chemical formula of elements can be written. See, there are elements which can exist independently. Say helium. Helium is represented by He. Okay? So the elements which can exist independently, they can be represented by a single letter. But which cannot exist independently, you have to find out that how many atoms are there in its one molecule. Okay? So do remember of oxygen, nitrogen, chlorine, fluorine, right? Now, the number of atoms present in one molecule of an element is known as its atomicity. Say, in one molecule of nitrogen, there were how many atoms, or there are how many atoms? 2 atoms of nitrogen in one molecule of nitrogen. So what will be its atomicity? It will be 2. 2 is represented by di. It is diatomic. You must have heard of ozone. There is an ozone layer in the atmosphere which prevents the entry, or which restricts the entry of UV rays. So that is represented by O3. So O is the symbol of oxygen. So how many oxygen atoms are there in ozone? 3 atoms of oxygen in one molecule of ozone. Right? Now, a number of elements such as helium and neon exist as single atom. So they are called as monoatomic. How will helium be represented? Helium will be represented by He. Now it exists as a single atom. Its one atom is stable. Neon. Likewise, neon. Neon is represented by capital N and E. Argon, that is a gas present in the atmosphere, it is represented by Ar. Now these are the elements whose single atom is stable. Right? We'll not go into details why they are stable and why others are unstable. The molecules of hydrogen, nitrogen, oxygen, chlorine, bromine, etc. contain two atoms of the element respectively, and thus their atomicity is 2. Such molecules are said to be diatomic. I told you, two atoms of hydrogen combine and make one molecule, so it's H2. Hydrogen single atom is unstable. Two atoms of nitrogen combine to form a nitrogen molecule. Single atom of nitrogen is unstable. Again, two atoms of oxygen combine to form one molecule of oxygen, and it is represented by O2. Two atoms of chlorine combine to form one molecule of chlorine, and it is Cl2. Likewise, Br2. So, in one molecule of these elements, how many atoms are there? 2 atoms. So their atomicity, that is the number of atoms in one molecule, is how much? It's 2. So such molecules are said to be diatomic molecules. Now, there are molecules in which there are more than one atoms. Like a molecule of phosphorus has 4 phosphorus atoms. So phosphorus will be represented by what symbol? What is the symbol of phosphorus? P. How many atoms are there in its one molecule? 4. So 4 will be represented as a subscript. Thus, a molecule of phosphorus is tetraatomic and its atomicity is 4. A molecule of nitrogen has 2 atoms of nitrogen in it. Its molecule can be represented as N2. So, symbol of the element N2 and subscript showing atomicity of that element. So students, do remember hydrogen, oxygen, nitrogen, chlorine, bromine, fluorine, all are diatomic. Phosphorus is tetraatomic, that is 4 atoms of phosphorus are there in one molecule. Right? Helium, neon, argon, they are monoatomic, that is one atom is there in it, one atom is there. Right? It's single atom. It's stable, so it is represented by He, and it's called as monoatomic. Okay? So students, in this session we have studied about the symbolic representation of elements, about the monoatomic, diatomic and triatomic molecules. And in the next session we'll be studying about symbolic representation of compounds. Right? I hope you have enjoyed this session, and just go through the text you have. So thank you very much students for your patience, and do have a nice time ahead.